Hello, Maurieos Live 007 Survey Travis closure using Bowditch. Hello, welcome. Well, I've just this evening received an email from someone who knows me, a viewer, a subscriber, I'm not sure. And they've asked me about a particular question and said an example in that they're having a wee bit of trouble with. And it involves a Bowditch adjustment. Now, I've also had some previous requests for Bowditch work, and I did have that on my to-do list. So I thought, well, I'll kill a number of birds with a flurry of stones, shall we say, and I'm going to do it live. So if anyone's watching that's particularly interested in the Bowditch adjustment of a Travis, here's your chance. Let's get underway. So what I'm going to do is to just set up my big screen, or what I call my big screen, and just get everything underway so that and then I'll cut I'll cut to the big screen first of all, and here we go. So we've got one person watching, so feel free to join in with the chat, and I might do a little inset. Is it inset view? Yeah, I'll just put that across so you can see what I'm doing. So, well, this is the problem that's been sent in by the student. They said they've got an exam and they don't know. So, calculate the final adjusted coordinates of stations B, C, and D using the Bowditch method. Also, calculate the misclosure ratio. All right, so what we have here is a, you have to excuse me, my nose is running a little bit, so I keep scratching my nose. So what we have here is what we might call a link traverse, and it's not a closed traverse, it's going from a known point A to a known point E, and we've got the coordinates of those. Just a little point about those coordinates. They're actually coordinates written east first, northing last. Now, I'm based in New Zealand, so we always work with our northing first and our easting. But so be aware of that. This is a sort of kind of common thing. The easting northing is the sort of the mathematical one, where because the easting is in effect your east your x, and the northing is the y. But we always go northing first, easting, and our bearings are always measured clockwise from north. So you might, which seems to be the case here. So I think it's possibly just because this has been drawn in perhaps AutoCAD or something that uses that convention. So so this is the problem that we've got here, and we have to obviously see how it closes between this coordinate here and this one down here at E. So I'm just going to put that over there to one side, and then what I've done is I've done a little spreadsheet here in Excel, and this is available if you want it. If you just email me, I can send you an example of the spreadsheet. I can see that my head's a little bit in the way there, so we might have to get me out of the way at some point. But anyway, so here we are here. Oh no, I'm there on that screen. So I'll do that now. I'll just you don't want to be looking at me anyway. So so what we've got here is, first of all, our traverse. We're going from A, B, C, D, E. and our coordinate of, I've put a coordinate here of A up here. Now I've put the northing first, 3232.178, and then the easting 5123.362A. And then we write in the vectors or bearing and distance from A to B goes there. So this top column here is always blank. We never write in there, just the coordinate of A. So we go A to B, which is 100 degrees 2340 and 125.659. We must make sure that it's going in the right direction. So this is our north up here, so 100 degrees is in that direction. Next we put in our second bearing, B to C, 155.49, and that's 148.222, and that's written in here. I've had to write the bearings in this format because, as you'll see, Excel doesn't work in degrees, it works in radians. So we need to convert everything to radians to use the trig ratio, sine and cosine in that. Now, I've done this in an Excel spreadsheet so that I can be quite sure of my answers, but I will show you how to get all of the answers using a calculator. So I've got a little calculator available here that we can put up there and use that, and that'll work in, as I said, that works in degrees. This is a fairly common calculator that's available here in New Zealand in most stationery shops. Most students have these, or they have a graphical calculator, which, yeah, I don't really. I can work just. Okay, now I've put the black information is what we know, and the red information is all of the stuff that I'm going to calculate. Okay, all right, so let's get on now, and then we've got 128.3140 for 162.895 and 171.1900 for 82.671. Now I would say that it's always important that you check your bearings right at the start, that you've got them written down correctly, because one mistake there, it screws everything up. All right, and then what I've done down here is I've written in here the published total coordinates for E. So you'll see here 54438.822 and 2890395. Now they are the published coordinates, and they're what we're aiming for here. That's what we should get in here. Okay, that's what we should get. Now I'll show you here. This is obviously the answers, so I'll just what I'll do is I'll just delete those from there. And what you'll see, of course, is this is in the northing, and I'll delete those from there, just for now. And I'm just going to, and these you can see here that if we take those out, we get a value in here, 2890246, and that's the unadjusted value. So what I've got to do is we've got to make sure that these two endpoints, that this one and this one agree. I'll just go Control Z. I might have hopped a bit forward a bit too late there, and yeah, things there. But anyway, so these are the total coordinates. Now, so the difference north between A, which is known, and E, which is known, is this value here. So if I just click on here, you can see on the spreadsheet that it's J15, which is here, J15 minus J6. And if I click on here, it's, oh, sorry, this one, not that one. If I click on here, it's K15 minus click there. K15 minus K6. So that's the difference north and difference east, and that's what we want everything to be equal to for it to be right. So I'll explain that now. So now we've got all our bearings and distances in, and we've checked that they're all okay, and we've checked our initial coordinate. So now what we've got to do is to run out our northings and eastings. Okay, and the way we do those, well, I could maybe, I'll just, I'll take these out of here for now. I'll just, before I do that, I'll just save that. So I know I've got a version of it like that. Now I better save that somewhere, hadn't I? I'll browse. I'll save it in. I'll save it to the desktop. That's always a safe place. If I can only find the blooming desktop. We'll have to go down here. Oops, this is proving elusive somewhat. Here it is, the desktop, and we'll call this Bowditch 1. Bowditch 1. Get your spelling right. Bowditch 1. So that's on the desktop if I lose the plot somewhere along the line. So what I'm going to do is I'm just going to delete those, and I'm going to delete those there. Okay, so at this stage we don't have anything in there. We're going to work out these northings and eastings. Now, one way of doing the northings and eastings is to get their calculator, and first thing is to make sure that you're in degrees mode. So shift mode degrees, which is 3. Okay, shift mode 3. So we're in degrees. That's all good. If we look up here, you can see DRG there, but I can't see where the D's highlighted. It's a little bit small, actually, that little part of things. All right, so now the easiest basic way is to take the cosine of the bearing and multiply it by the distance, like this here. So we go cosine 100 degrees, 23 minutes, 40 seconds, and we close the brackets. Oops, that wasn't. We close the brackets, and then we multiply by the distance. 125.659, like that. Okay, and you can have a picture of me there for a little while. 125.619, and you go equals shift mode 6, which is fix 3. Okay, so I've fixed it to 3 decimal places. If your distances are shown to 3 decimal places here, show them to 3 decimal places in your answers. So everything's to 3 decimal places. That's generally the way of things. So that's what I've done there, and that gives us, that's where you get negative 22.672. Now if you do it this way, you put the bearing in and you put the distance like that, take the cosine, you'll get the correct sign and everything here. So cosine bearing times distance. And then for the easting, it's the sine of the bearing times the distance. So I don't know whether we can come back here, possibly. I'm not sure. And go delete, and then go sign. Well, yeah, we can. And then just push equals. And we get 123.597. I've never done that before, so you learn something all the time. So that's that one there, like that. So I'll do the next one using that method, and then I'll show you another method. So I've got another method that we can use up here. Okay, so I'll show you that. So right, so let's get our calculator back. It keeps disappearing. Okay, so let's now go for this one, which is cosine 155 degrees, 49 minutes, and 0 seconds. I'll put them in. All right, close the brackets. Times 148.222 equals negative 135.214, and then we can come up to here and we can go back to there and change that to sine. I like that because it's sort of foolproof, although if you make the same mistake, and you'll make the same mistake twice, I suppose, equals 60.720, and it's giving the signs and everything. So that's all very good. Now there is another way of doing this. Just remember that these are rectangular coordinates. The delta n and delta e, so your rectangular coordinates. And I've got one person watching, but nothing in the chat. So if you've got any questions, by all means, let me know. So we can do these here. So let's just clear. These, as I said, are rectangular, and these are polar. Bearing and distance are polar coordinates. So if we want to do that, there's a little function over here, shift, and it's rectangular there on the negative button, rectangular. Now you put the distance first, 125.659, 125.659, and then you've got to use the comma, shift, comma, and then you put the bearing, 100 degrees, 23 minutes, and 40 seconds, 40 seconds. Close the brackets, and you push equals. And there, it doesn't give it to you in the number of decimal places, so you have to do negative 22.672, that's all good. And then if you move along here, move along, 123.597. Now the information is also stored in these X and Y storage registers, so you can get it to 3 decimal places if you go recall X, negative 22.672, and I was a little bit unsure about recall Y, 123.597. So that's another way of doing it, and I've written it up here, as you can see. So it's rec, R-E-C, which is there, which stands for rectangular, and it's the distance and the bearing, the other way around to what I did it before, and it'll give you the values. Okay, so now we go through and we get all of these values here, from A through to E, get them all here for northing and easting, and we add them all up. And what you can see there is if we add them all up, we get down here the difference. So in this case here, we've got a misclose of negative 0.149. And here we've got a misclose of negative 0.161. So this is we add all these. Sorry, in here you start here and that plus that to there, but you go right through to the, you don't write the coordinates in just yet. So it's that plus that plus that plus that plus that, or in fact that plus that will give you this value here, and that plus that will give you that value there. But it's the difference between these two values. These two values here need to be equal. So what I did down here is, you'll see I've got a, what I did there is I worked out what, oh no, that's, yes, oh, this here is the misclose. Sorry, that's a whole nother, that's another ball game there. So, oh, -1. Oops. Don't worry about that. So this here, what I've done is worked out the difference. So this one here is in fact that minus that. So that's what it should be, and that's what it is. So you can see 341,932, 341,783. If I just come out of there, you've got to add 0.149 to that to make it equal over here. And that's the misclose. And similarly here, if you look at this one here, I've got, what I've done there is I've got, this is what I've got, this is my delta n, and this is what it should be. And you can see that this is 315,621, and this is 315,460. So we've got to subtract from that negative 1.161 to make it equal. So that's the adjustment, right, like that. Now, just before I go a little bit further, I do want to show you that what's going on in here. This is a little formula to work these out. So first of all, it's the cosine there, which you can see that I'm using the cosine and I'm using the bearings to work it out. So they all go in there. But what I first of all have to do is to make the bearing 100 degrees 2340. I have to make that into decimal degrees, a degree in the decimal. Then I divide that by 180 degrees and multiply it by pi to make it equal to radians. Okay, so I take the cosine, decimal degrees, divide by 180, multiply it by pi, and then multiply it by the distance. Now, then I also have to round it to 3 decimal places, because if I go beyond that, I start getting some problems with the Bowditch and things like that. So everything's rounded to 3 decimal places. So this, I've got that up there. You can see what the formula is and work it out. Or if you want to get a copy of the this email, this Excel spreadsheet, just email me and I'll send you a copy. Okay, so I'm going to go now and go Control Z and get that stuff back. All right, so now what we've got to do is the Bowditch adjustment, which is written here. Now the Bowditch adjustment is the misclose, which is this value, or I'll just click on these here. The Bowditch adjustment is the misclose, which is this here, divided by the total distance, which is this value over here, 149, and then multiplied by the distance for each one. So the adjustment or the adjustment or corrections are applied in proportion to the distance. So you're going to get a larger correction in the larger distance, and the smallest distance will have the smallest correction. So I go through and I do that for each one, as you can see here. So and then I check that it adds up to 0.149. Now Sometimes it doesn't add up to 0.149 because of small little rounding issues. And if that's the case, you just make a little bit of an adjustment here or there so that it does add up to exactly that number. Because if it doesn't add up to exactly that number, you won't get the right answer here. You'll be out by the amount that this is out because you try to make it exactly equal. So sometimes you do get these small rounding issues. Another thing is that adjustments are just that. They're just small adjustments. And in fact, these adjustments here seem quite large. I'd have to say that if this was a traverse of my work, I would be quite disappointed. However, it's not uncommon to get larger miscloses in a link traverse because obviously it's not your own work, it's someone else's work, and the coordinates could be sourced from different areas. So when you are working with a link traverse, sometimes large adjustments come about. One of the ways that I would, with this problem here, is what I would do is check to see. I would probably do a GPS this line from A to E, and with the GPS, and then to just check that. I'm assuming that my work would be A, B, C, D. So I would make sure that my work's got no error in it, and so that I know where the error lies, if the error lies with the underlying work or whether it's in my own work. But that might be going a bit beyond the scope of this just at this point. So yeah, that's the Bowditch. There it is, and then you do the same for the easting. So here it is here, and you can see that it's the misclose east, which is 0.161, divided by the total distance, 519.447, and then multiplied by the distance. And it's just a proportion, really. And then that gets applied there, and obviously the biggest correction will be in the biggest line. It's the next biggest line, the next biggest line, and that's the smallest line. And they all add up to 0.161. So now is the time that you then, once you've got that all sorted, this is the time that you do your coordinates. And that's when you go from here, you take this coordinate, minus that, plus that, give you that coordinate. And then minus that, because it's a negative, plus that, give you that coordinate, minus that, plus that will give you that coordinate, and minus that plus that will give you that coordinate, which should equal the published coordinates for E, because that's what you're adjusting to. So now you'll see that if you go that plus that, it's going to give you that value there, and that minus that plus that will give you that value there, and plus that minus that will give you that value there. And what I've got down here is just a little check to make sure that when I check there that minus that is equal to 0, because if it's not, I've screwed up. And similarly here, and then I've just used a little bit of conditional formatting so that it goes green, so I know it's good. So if these don't add up, it doesn't go green, and there's some other numbers in there. And this okay, so that's pretty much it, really. That's the the Bowditch sort of thing. It's all resolved, and we've got the coordinates of A, B, C, D. Now, of course, we want to work out the misclose. Now, the misclose is quite simple, really. It involves basically, these are our corrections here. So I'll probably, if I use my diagram here. So when we're unadjusted, we get to a point here, and actually a point here, and we find that we've got to go a further 0.149 here, a further 0.149 north, okay, to get to there. And then we've got to go a further 0.161 west or negative. And that's going to get us to our point here, our point E. So we're at some point E dash, shall we say, that's E prime. That's sort of not, it's close, and we've got to adjust. So you can see that that's going to be a right angle triangle. I haven't drawn the little right angle in there, but that's there. So obviously this distance here, just using Pythagoras, we get 0.149 squared plus 0.161 squared. Take the square root of that, and the answer is 0.219, which I've just worked out here. If you can see, I've got that's this squared plus that squared, taking the square root of it. Okay, so that's the distance misclose there. And then to work out the ratio, well, the ratio is just the distance here divided by that misclose, which is it's 519.447 divided by which I've got here, I think, in the spreadsheet. Yeah, just that divided by that, and that gives us our misclose, which is 1 to 2368. The ratio 1 to 2368, which is just put in there. So it's just your length of your misclose, worked out by Pythagoras really, and divided into the total distance. Now, when I do this with my students here in New Zealand, I also like to ask them to give the bearing and distance of the misclose. So in this case here, I should perhaps write it down in here actually. So it'll be 0.219, which I've forgotten to fix there. That should be a 9. So I wonder if I can do that. Tools. Comment. Pages. I'll just put a little text in there. Is that the one? I'll just put a 9 in there. Okay, and that should be, oops, I wonder if I can, okay, Control E, oops, no, won't do it, I'm trying to make that go. I might just put it in a text box, it's easier. 9. Oh, and then I can do Control E. I wanted to make that a bit bigger. That doesn't seem to want to let me. All my Won't let me make it bigger. I'll try another, add a text box here. 9. Yeah, that's better. Perhaps I need to make my text box bigger. No, delete. Make this text box bigger. Delete. Oh dear. Anyway, that's got rid of it. I don't know, that's got rid of the text box. This one here. Oh yeah, 36. I probably can go with 18. No. Oh, no. Oh dear. Sorry. Yeah. So let's just put that in there like that. Make that there. 18. Perhaps a wee bit bigger. 24 perhaps. Yep. And I'll move that 9 to there. Equals 0.219. Okay, so that's fixed that up, equals 0.219, which is what I've got there, and 47, negative 47 degrees 13. Oh, right, now the bearing. All right, so the bearing is always measured clockwise from north. So this is the bearing here, okay, and obviously the angle that we can calculate is this one here, tan to the negative 1, 0.161 opposite over the adjacent 0.149, and we work that out, and that's 47 degrees 13 minutes. Okay, and then we've got to take that away from 360 to get the bearing, and the bearing is 312 degrees 4700. Okay, now there is another way of doing this, and that is with the using the polar conversion on the calculator, which is on the plus. So we just go shift pole, and then we put in our two things that we've got, our two delta ends. So we've got 0.149, and then we use the comma, and minus 0.161. Close the bracket and push equals. And there we get our distance, 0.219. And, well, yeah, we can, I think it's probably, and we can get our bearing over here, but you'll notice that the bearing is negative, and it's that negative 47. So what we can do is go recall X, which is 0.219, which is good, and then we can go recall Y, which is there, and then we need to, because it's a negative, not because we know, well, we know that it's a bearing for the previous thing, but just because of the negative numbers are measured anti-clockwise from 0, negative bearings. So we just add 360 plus 360 equals, and then we do that, and there we get 312 degrees 47. Okay, so that's that all sort of sorted, really. So we get 219, and then I'll put at 312 degrees, out 248. Hold down the out key, and push 248, and 47 minutes. Okay, and that's pretty much it. That's it, all sorted. Just to possibly, I will go to the thing here. I've got no chat here, so just the one person watching. I don't quite know how that all works. I think it might be actually me, just watching on my own, but never mind. Okay, so yeah, what we had there, of course, was we had our I think we can get rid of, can drop our calculator down, and we can go we can get rid of those, give ourselves a bit more room, and we can go page, we don't need that, and we can go page up. And so yeah, there we are. We had our little problem. We keyed in our bearings and distances. We've worked out our deltas, worked out our deltas, applied them to our known coordinates to get our differences. Okay, and then using those differences, we worked out our Bowditch adjustment, which is fairly straightforward. It's written up here, and then we applied that, closed out our coordinates, worked out our misclose using Pythagoras, and then divided that into the total distance. To that gave us our misclose of 1 to 2,368. Now realistically, I mean, that can, a millimetre here or there can make quite big differences to that. So realistically, probably call that 1 to 2,300. It's not great, but it's to be sometimes expected with the link traverse, where you're going from one set of data to another, possibly. I don't know what the situation is here. So that's it. All sort of sorted. Possibly just drop down to the second page here, just there, and you can see there's a lot of crossings out there. What actually happened was I had these here set for 2 decimal places, and I didn't realise right till the end, until I went to check these on the calculator, that I was only showing them to 2 decimal places. With my rounding, it was making all these 0. So they just made some slight little differences. That's what those differences are there, if you just put in the did them to 2 decimal places rather than 3. So it's sort of a bit of a self-checking process. So there you are. I hope that enlightens you further on Bowditch adjustment, and we'll wait and see what you say. No, didn't get any live chat response there. We've been going for some 43 minutes. So that's pretty much it. It should be up on YouTube within an hour or so. I might have to do a small amount of editing. I hope not, which can delay it. So it should be there pretty soon anyway. Cheers. See you.